Hi, my name is Adrian. This is lesson 5.6, rates of change in rational functions. If you're not subscribed to this channel, feel free to subscribe. If you need tutoring with regards to advanced functions, feel free to click the link in our description below. We'd love to get in touch with you guys to help you guys ace this course. But without further ado, let's get straight into it. So in lesson 5.6, rates of change, we know there are two types of rates of change. There's the A-rock and there is the I-rock. And remember, with the A-rock, they give you 2 points, but with the I-rock, they give you 1 point. Now, A-rock meaning average rate of change, I-rock meaning instantaneous rate of change. So we're going to go through a couple questions. We're going to start off with a simple one, and then we're going to go into some word problems. So in this question, it says y equals 17x plus 3 over x squared plus 6, where x equals negative 5. The first thing you got to determine, is this an A-rock question or is this an I-rock question? By the looks of it, I see they only give me 1 point, so we're going to do the I-rock. Now, for those of us who are trying to remember how to do the I-rock, now we will, in advanced functions, you learn how to approximate the I-rock using the A-rock. But in calculus, you can use derivatives to find the I-rock in a seamless way. But for this course, we're going to use the approximation method. So what we have to do is we got to pretty much get a point on the right side of negative 5 and on the left side of negative 5, and we're going to set up this equation. So we're going to have negative 5.1 minus f at negative 4.9 over negative 5.1 minus 4.9. So this is going to be how we're going to set up this equation. So let's find these out first. So let's find out f at negative 5.1 is going to be 17 times negative 5.1 plus 3 over negative 5.1 squared plus 6. So 17 times negative 5.1. So this you get negative 83.7 all over 32.01. And then this gives us negative 2.6148. 2.6148. Now I want to always get like at least 4 or 5 decimal points because I know as these questions get more precise, we need more decimal points to increase the accuracy of our answer. So let's look at the next one, f at negative 4.9. So f at negative 4.9 is going to be 17 times negative 4.9 plus 3 over negative 4.9 squared plus 3. So what does that give us? Negative 4.9 times 17 plus 3 divided by negative 4.9 squared. So we get that. So here you get negative 80.3. And then the bottom, you'll get negative 4.9 squared plus 3. So you get 27.01. So here you get negative 2.9729 as the answer. Now, with that being said, now what we got to do, guys, is we actually have to go through and plug these in as these answers. So this and this guy are going to come in over here. And then we're going to complete the equation right off the bat. So we're going to have negative 2.6148 minus negative 2.9729 over negative 5.1 minus negative 4.9. Now you want to be really careful with these negative signs because this is how a lot of people mess this up. This is why I put the brackets, because eventually we're going to have to take these two negatives and make it into a positive. So let's do that in the next step. We'll get negative 2.6148 plus 2.9729 over negative 5.1 plus 4.9. So we know this is going to be negative 0.2. And the other guy, negative 2.6148 plus 2.9729. So you get 0.3581, and then divide that out by negative 0.2, and you get negative 1.7905. So this is our answer for the IROC. So as you can tell, guys, it's a pretty straightforward process. The main thing, IROC, it has 1 point, but from that 1 point, we need to get a point slightly to the left and slightly to the right of that point. That's why I chose the 5.1 and the 4.9. Okay, so you want to make sure that you get those 2 points, then the rest is just math. Cool. Let's go into our next problem. So our next problem, we're going to be doing a word problem over here. Let's move this down a little bit. Okay. So a small clothing company, the estimated average cost function for producing a new line of t-shirts is this. C at x is equal to x squared minus 4x plus 20 over x, where x is the total amount of shirts produced in thousands. This is a key word, in thousands. And C of x is measured in dollars, okay? So let's look at the first part of the question. The first part of the question is saying, calculate the average cost of a t-shirt at a production level of 3,000 pairs. Now here's the thing. The t-shirts are produced in thousands. This is a key word. And this is where a lot of people mess up questions like this. This is a key word. So 3,000 pairs is actually going to be equal to C at 3 is what we're trying to find, because it's in thousands. So let's find out what C at 3 is off the bat. We got 3 squared minus 4 times 3 plus 20 all over 3. And this should give us 5.67. So this is the average cost at 3,000 pairs. So when we produce 3,000 pairs, the average cost of each t-shirt is going to be about $5.67. So the key thing here, guys, is just the word thousands. Let's look at part B. Estimate the rate of change, the rate at which the average cost is changing at a production level of 3,000. So what this is basically trying to say is, okay, 3,000 t-shirts is at 3, right? But it's basically saying we want the IROC at 3. And the reason we want the IROC at 3 is because it only gives us 1 point. Remember, if they gave us 2 points, then we would know it was the AROC. But because it only gives us 1 point, which is 3,000, which converts to 3 because of the thousands, we know it's 1 point. So what we have to do is we have to take the 3.1 and 2.9. So 2 points really close to that. And we got to solve this out like that. So if we actually put this in our calculator, 3.1, we'll get 3.1 squared minus 4 times 3.1 plus 20 all over 3. Let me move this other question down. And then when we put that in our calculator, we'll get approximately 5.55. And then we'll do the same thing for 2.9. So 2.9 squared plus 4 times 2.9 plus 20 over 3, which gives us 5.79. Then we actually just plop this into our equation up here. So we end up with 5.55 minus 5.79 over 0.2. And we end up with negative 1.2. So what does this negative 1.2 means? It means that when we're selling 3,000 t-shirts, we're actually slowing down the rate at which we're selling. So the price of the t-shirt decreases about $1.2 per 1,000 t-shirts. So this represents a decrease of approximately $1.2 for every 1,000 t-shirts. So notice how when I did in part A, it was really just asking for the average cost, which is pretty much a set number. The average cost is just how much does this t-shirt cost? But for part B, when it's talking about the rate, right? The key word is rate. when it talks about the rate, we are actually not just talking about how much the t-shirt costs, but we're talking about how is the price of the t-shirt changing as we produce more t-shirts. So is the price decreasing or is the price increasing? It's more of a rate type of question. Versus part A, where it's just asking you, hey, how much does a t-shirt cost at 3,000? Right? So this is some important terminology I want you guys to know for these kinds of word problems, because this is where a lot of people mess up. Okay, let's move on to another one. Question 10. Okay? In this question, it's saying for the part A, well, first of all, we know that number of houses in a new subdivision, that's what we're trying to find. The number of houses is represented by this equation, where n is the number of houses from 0 to 12, and t is in months. Sorry, where n is the number of houses, and t is the number of months. So there's a bunch of key words here. T is the number of months, and notice how it gives us this inequality from 0 to 12, because obviously within a year there's 12 months, right? So the first part of the question is asking, calculate the average rate of change, keyword, average rate of change in 6 months, over the first 6 months, okay, over the first 6 months. So what is that question asking us? This question is basically saying, it's saying we want to find n at 6 minus n at 0 over 6 minus 0. So let's put that in our calculator. If we got n at 6, we're going to have 100 times 6 cubed over 100 plus 6 cubed. That's n at 6. Minus n at 0, which is 100 over 0 cubed over 100 plus 0 cubed, all over 6 minus 0. So when we do out this question, we'll get 6 cubed times 100 divided by 100 plus 6 cubed. Is that? So here you got 68.35 minus 100 times 0 is 0, so then the whole thing becomes 0, all over 6. So what we end up with is 11.39 is the average rate of change of number of houses built over the first 6 months. So 11.39 is going to represent the number of houses built per month. So remember, this is the rate of houses built per month in the first 6 months. Okay? So it's how fast are we building houses within a 6-month period from 0 to 6 months? We're building about 11.39 houses per month. Cool. So part B is saying calculate the instantaneous rate of change. So instantaneous rate of change of number of houses built at the end of the first year. So instantaneous rate of change, we're talking about 1 point, and it's at the end of the first year, so it's happening at month 12. So how do we do that? What we're going to do is we're going to say n at 12.1 minus n at 11.9 over 12.1 minus 11.9. So what is n at 12.1? We're going to have 100 times 12.1 cubed over 100 plus 12.1 cubed minus 100 times 11.9 cubed over 100 plus 11.9 cubed. So notice how I'm just putting this neatly into my formula. All over 12.1 minus 11.9. Okay, so now we actually just got to do some math. So I'm just going to put this in my calculator. 12.1 cubed times 100 divided by 100 plus 12.9. 12.1. Oh, I put 12.9. 12.9 cubed is that times 100 divided by 100 plus 12.1 cubed. So here you end up with 94.656 And I want to get as many decimal points as I can just to improve my accuracy. So about 4 decimal points would be pretty good. And then we're going to do the next one. So 11.9 cubed times 100 divided by 100 plus 11.9 cubed. You end up with 94.3983. All over 0.2. So 94.6569 minus answer divided by 0.2. You end up with 1.293 as your answer. Now, what is this? This basically tells us this is the number of houses built per month at month 12. So remember, this is a IROC question. This one was a AROC question, right? So this is between 0 and 6 months, but this one is at 12 months itself. So notice, right, this concept, guys, is very similar to all the other chapters we did when it comes to AROC and IROC. The most important thing that you have to know is you have to identify, is this an AROC question or is this an IROC question? And depending on if it's AROC or IROC, if it's AROC, it gets pretty easy because you're just taking the 2 points and then doing the formula. But the IROC, you got to find out what is that point that the IROC is asking. And from that point, you're going to formulate your equation. So if you found this video helpful, guys, drop a thumbs up. It really helps the channel grow. Thank you guys for supporting the channel, and I will see you guys in the next video. Peace.